Alright, welcome to the early morning video, one of the best videos ever. And even better than that, the topic I'm going to be looking at today is basically the most timely topic ever. I'm going to be reading about machine learning operations and machine learning engineering. So it is now 2024, which is about 4 years after this book was written. And if you didn't believe them at the time that one of the hottest job titles in 2022 is machine learning engineering, well, it's time to get on board because that has turned out to be more than true in hindsight. Other hot job titles include data engineer, data scientist, and machine learning scientist. While you can be a DevOps specialist, DevOps is a behavior, and the principle of DevOps can be applied to any software project, including machine learning. Let's look at some core DevOps best practices. Continuous integration, continuous delivery. So this is CI/CD, that's what it stands for. The CI stands for continuous integration. The CD stands for continuous delivery. The next DevOps best practice is microservices, and that's a big one too. That's kind of a tricky one to get a handle of. It might seem like a monorepo is the way to do things, so it's not all scattered around different repositories, but a best practice of DevOps is to use microservices, infrastructure as code, monitoring and logging, and communication and collaboration. Which of these doesn't apply to machine learning? And it's a rhetorical question. None of them don't apply. They're all critical for machine learning. The more complex a software engineering project is, and machine learning is complex, the more you need DevOps principles to handle the complexity. Is there a better example of a microservice than an API that does machine learning prediction? In this chapter, let's dive into the nitty-gritty of doing machine learning in a professional and repeatable way using a DevOps mindset. Alright, so what is machine learning? Machine learning is a method of using algorithms to automatically learn from data. There are 4 main types: supervised, semi-supervised, unsupervised, and reinforcement. Before I go on, I actually am really sold on AI. So I just want to look quick for my own curiosity here at what kind of degrees are offered at this school, because I've looked into this school before. So data analytics, I guess, is the closest one. But looks like there's nothing directly for machine learning well, one thing that there definitely is for AWS or for Azure. If I go to career technical development and then certifications, there's a AWS certification path in machine learning. I think it's important to be aware of some of these official, CCNA like paths to working in these fields, because these fields, obviously, with ChatGPT, it's clear to see, aren't going anywhere and are not just hocus pocus. And not only that, they're basically the number one thing that companies want is let's see here, I thought it said it in the book. Yeah, it is a method of using algorithms to automatically learn from data. All right, so supervised machine learning. In supervised machine learning, the correct answers are already known and labeled. For example, if you want to predict height from weight, you could collect examples of people's heights and weights. The height would be the target and the weight would be the feature. Let's walk through what an example of supervised machine learning looks like. So you have the original data set, which I will click this link. And this takes me to kind of an O'Reilly link, and then it redirects me to a wiki link. So here's a data set of 200 individuals, each with a different height and weight. So we've got some people who are weigh less. We've got some people who weigh more. $25,000 synthetic records of heights and weights of 18-year-old children. Okay, I don't see where that one is. This one, it looks like it's only 200. So, maybe so this is a sample, and that's important to know too. There's a lot of like really heady scientific, mathematical concepts in data that are a little bit hard to get your head around. If during the pandemic there were a lot of really kind of heady mathematical things like exponential growth, that it was obvious that the average person in especially US society is basically orders of magnitude mathematically illiterate. So like I would say if you want to get into data science, like try to like get a sense of your mathematical literacy, and if you're not very mathematically literate, I would definitely try to work on that somehow. I've had videos on this channel where I go through Khan Academy, which I think is a great tool. There's also like Brilliant, but if you're expecting to do well in a something like data analysis, and you know you've only made through like middle school, like low level high school math, like I would definitely, and the other thing is like this kind of stuff is fun. Like math is fun. This is fascinating. So like here's the question: a sample of 200 individuals is selected, and so like sampling is a math problem. So data sampling is the data analysis practice of analyzing a subset of data in order to uncover meaningful information from a larger data set. And I feel like this is another kind of like exponential growth was absent during the pandemic. I feel like data sampling is absent from US society. The standardized testing for all students in every classroom and everything could be replaced by data sampling, and the data would be more or less as accurate, and then you would have more class time for things other than just taking standardized tests all day. So like that basic mathematical, not even that high level to be honest, concept is missing from colloquial society. Everyone should know what data sampling is, because people should be part of like, you know, oh, we got data sampled today, we had to take a test, it sucked, you know, instead of we have to take a test every day because society at large doesn't implement data sampling for some reason. So yeah, a lot of interesting, fun concepts in machine learning. So excited for this for sure. So here we go. So this is ingest. We're going to import pandas as PD, and here's that list of 25,000. So I think I am going to type all these out just because I'm really kind of all in on this subject. I think it's, you know, as I mentioned, being able to understand some of the mathematical concepts at least is key. Like having a basic literacy in the subject, I think, is key, even if you're not working in it actively. So I'm definitely going to do these examples here. So let me pause it because I might have some, you know, information up from before, and I'll make sure my environment's good. All right, so my environment's good to go. I don't have anything cluttered around, or my AWS ID isn't just sitting there ready to be accidentally exposed. So I'm going to pull up. So I don't have pandas, I believe. If I do a IPython 3, I definitely recommend always use IPython over Python. It's just great. So I don't have IPython installed either. I think I'm going to make a virtual environment. You know what? Let's do this all in a folder, because then it's so much easier to delete. It's all contained in that folder. If you want to get rid of all the files, you just delete the folder recursively instead of having to dig through and delete the files you want to delete and not to delete anything else. So it makes it a lot easier. So I'm going to do mkdir, and I'll name the folder. What will I name the folder? I'll advance the bookmark here, and then I'll delete this, go back to here. So I'm going to say Python for DevOps Chapter 14 is what I'll name it. So Python for DevOps Chapter 14. Okay, and then change into that directory. And now I can get rid of this older bookmark for location 3.7 and skip ahead to the newer one. Oops. Oh, this is an older bookmark as well, so I'll get rid of this one too. All right, and now skip ahead to the latest one and do this example. So I'll create a virtual environment. Okay, and now I'll do a pip install -- upgrade pip. Now pip install, and then we'll do IPython first. There we go. And then a pip install of pandas next. Perfect. Okay, so now I should be able to do the examples. So I'm going to do IPython, and I don't need to do IPython 3 because I'm in that virtual environment, so it knows what I mean. Import pandas as PD, df, so data file, I think that's what that stands for, equals PD, stands for pandas, read CSV. And now we can actually reach out to the internet and get the CSV from the internet. Cool. And one really cool thing now is I can actually copy and paste now. I wasn't able to do that before. It gives me this extra information to credit the book, but hey, I'm happy with that. So we got a special syntax here. We've got the URL that we're reaching out to. Then we've got a Noah gift here, regression. I'm not sure exactly what the syntax is all about, but hopefully it works. I'm going to try it. Okay, so it can't contain control characters, so something went wrong there. We can see it didn't paste the same way it was in the example, so I think that's where I'm going to start is to make it the same as it looks in the example. Okay, so this is how it looks in the example, but I think this might be a problem. Yeah, so I'm going to try getting rid of this as well. I think there's a typo in the example. Oh, same problem as well. So it can't contain control characters. So yeah, so here's an extra space. So I'll get rid of that space. A space is a control character, apparently. There we go. And I've got the file. If I were to do a look at the file, now it's, well, let's see what this is. Let's see what df is. Df is a pandas data frame. So let's see everything you can do with a pandas data frame. So a pandas data frame. So it's a data structure that's, so it's a two-dimensional, size mutable, potentially heterogeneous tabular data. Woo. Okay, nothing better than that. You could build a country song around that. I think two-dimensional, size mutable. You know. Okay, so data structure also contains labeled axes, rows and columns. Arithmetic operations align on both row and column labels. Can be thought of as a dict-like object for series objects, the primary pandas data structure. So it contains labeled axes, rows, and columns. So here we go. Here's the rows that are labeled 0 through. So this is important to note. It starts with 0 instead of 1. So there are 25,000 entries, but the first entry is entry 0, and the last entry is not 25,000. It's 24,999. Then the rows are columned. The first row doesn't have a label. Now this is interesting too. So even though it starts at 0, one of the values of the columns of the row is the index value. So here it does start at 1. So you can choose to either interact with it with this 0 to n minus 1, or with just the actual value of the entry. So if it's the first entry, you can interact with it by the index column instead of this first column here, and you can use the number 1. Then we've got height inches and pound weights. All right, so the next part is df-head, or df.head. All right, and this should match the output here. So head, that is, we can do a help on that, but the Linux command head shows the first 10 lines of output. It looks like we've got the first 5 lines here. So it looks like in this case, yeah, head returns the first n rows. So you specify how much. If you don't specify, then the default we see right here is set to 5. We can see that here as well. Default is set to 5. So we're seeing the first 5 entries in the file because of the default behavior of this .head method. All right, so let's see if it looks similar. So yeah, it looks pretty similar to me. The first value at index 1 or at 0 here is around 65. Looks good. And then the last one around 67. Let's see if that matches. All right, looks great. All right, next section is EDA. Let's look at the data and see what can be explored. Scatter plot. In this example, Seaborn, a popular plotting library in Python, is used to visualize the data set. If you need to install it, you can always install it with. And this is a special character for IPython, which is so great about IPython. And now they're using a Jupyter notebook as well. I'm not using that. I kind of need to get better at using that perhaps, but for now, I'm just going to continue not using that. So you can always install it with pip install Seaborn, and you can use a special character to remain in your interactive shell. You could also install any other library of the section the same way. So further on, if I'm missing a library, for example, I might be missing NumPy, I can do the same thing to get it. If you are using a collab notebook, these libraries are installed for you. See the graph for height and weight, and then this says LM. I don't know what that means. Plot. So okay, so yeah, so let's go ahead with this now. I need Seaborn, so I'm going to do import Seaborn as SNS, and look at that, no module named Seaborn. So what does that mean? That means I don't have it, so I need to install it. All right, and let's do the same for NumPy. I'm going to do import NumPy as NP, And I already have NumPy. I'm a step ahead. So now I do need to run that import seaborn command again because it failed. So I need to run it again so that the command is successful and it doesn't just fail. There we go. And since I'm in IPython, I can autocomplete. I can just use the right arrow to autocomplete. So the next line, and we can see it's an input line. So we have to feed some input to it. It's sns.lmplot. So that's what the LM is. It's a graph. The other thing I'll mention is typing is a pretty important skill as well. You can see I have to type all of this out, and that's not that difficult for me. So if you're struggling with typing, I would urge learning to type. I just think it's another one of those basic computer literacy skills. Now, the way I learned to type was in school, in middle school. I also used a piece of software called Mavis Beacon for a bit. I don't think I used it that much. And then I used just online typing tools. So that's what I would recommend is like free online typing tools. And try to get your word per minute to probably like at least 30 words per minute. And then definitely become a touch typist. If you have to look down at your keyboard all the time, I would work on that and try to be able to type while you're looking at the screen. Okay, so this LM plot didn't work. So now it's okay. So I've got multiple arguments for data. Is why it didn't work. Now, did I spell all of these right? Height, capital I, weight, capital P, data equals df. Multiple arguments for data. What the heck? All right, well, let me try just doing df. That makes no sense. Okay, I might need to do a ChatGPT discussion, but for now I need to take a pause, so I'll be right back. All right, I'm back. Let's get to the bottom of this. I've got a good half an hour here, maybe even a little bit longer than that, but I can get to my peak hour mark probably. So let's see here. We're going to open a new chat and then just paste this in here. Okay, so I think I accidentally put in the wrong oh, you know what? This is what happened. I mixed the positional arguments, try to put them as keyword arguments. Yeah, so this is, let me explain this. So there's positional arguments and there's keyword arguments in Python. A positional argument is given and known what it means because of the order, the position in which it was given. So if I were to define a function, now I could have positional arguments A, B, and C. So here, now I can do print C. So I can print them out of order like this. Then print A, and then print B. So how does it know to print C first, even though it's out of order? Well, it's because I gave C last. So because of the position of which the arguments are fed to the function, it knows which data fed to it belongs to which argument. So if I were to call that function, and I were to do 1, 2, 3, Now it knows to assign the number 1 to the letter A, the number 2 to B, and 3 to C because of the position in which I entered the arguments. So these are called parameters. When you define a function in Python, you give it parameters, and then these are called arguments. Right. So when you give arguments to a function, you can give the arguments positionally, or you can give them as keyword arguments. And it depends on how the function is defined. So here we can see we've got a function that is defined with parameters that are positional. So it knows which arguments to assign to which parameters because you assign them positionally. Let's say so the other way you can do it is to assign them with keywords. So we can do A equals 1, and now we can do C, or we can do, let's see here. Oh, you know what? Here's how you demo this. So now what we can do is C equals 1, B equals 2, and A equals 3. So you can see I've fed in the order of these arguments backwards now. Instead of feeding in the order positionally, 1, 2, 3, and then have it print out in this other order because it knows which positional arguments apply to which parameters. Now I can define specifically which arguments I want to belong to which parameters. So I want the argument 1 to be assigned to parameter C, which will get print out first, and the argument 2 to be assigned to parameter B. So I'm going to do it in a way where it will be the same result as it was before. So I'm going to do it just like it was here. So the parameter A, I'm now going to assign in the last position, but because I'm using a keyword argument, it will be it will know what I'm talking about. So there we go. We've got the exact same output as here before, even though the order of the arguments is now different. That's because in Python, you can pass arguments to a function either positionally, so that it's implicit, you know which is which based on the position. So this maps to A because A is first, this maps to B because B is second, and this maps to C because C is third. Or you can pass in the arguments in a using a keyword method where you explicitly take what the parameters are. So we have parameters A, B, and C, and you explicitly define those parameters as your arguments. So I defined C here as the argument 3, just as I did here positionally, but here I did it through a keyword. I took C there and I assigned it to 3, and then I did it for each of the parameters in the opposite order that I did it when I did it positionally, and it still had the same result because it knows which argument I fed to which parameter because I used these keywords to explicitly tell it. So that's my short, give myself a round of applause in there because I think I did a decent job. As I started in, I was worried like, oh wait, maybe I can't explain this too well, but it's, yeah, I'm really happy with that. So let's try this again. So the first thing I'm going to do is print off the df function. So I'm going to do df like this. And then what I'm going to do is bring up this again. And notice how kind of odd it is. We have a mix of positional and keyword arguments, and that's valid, but it's just kind of confusing. So I'm going to do all of them in positional arguments using keywords instead of using some with permissions and some not. And a way you can look at what the parameters are in Python is you can do a help. So now we can see all of the parameters here when we've got x and y are defaulting to none, so we can change the. And the other thing is, it looks like the solution to this problem is it's just out of order. Something must have happened between when this book was written 2 years ago and now, where for some reason SNS, which is pandas, I believe, which is Seaborn, they decided to flip the order for some reason, or there's just a typo in the book. So here we go, and delete this, and oops, still doesn't work. So yeah, and see is now there is some syntax requirements. You can't pass a positional argument after a keyword argument because the keyword argument changes the position. So this is now in position 2, but you're trying to pass in the argument as if it were position 1. So that doesn't work. You can only have keyword arguments after positional arguments. But in this case, we've got another error. So let's do let's do it like this, but now we're going to so height is so we're gonna plot height on the x-axis and then weight on the y-axis, and we're going to use everything with keyword arguments, no positional arguments, because that removes a lot of ambiguity. And we can see that works. It's to combine keyword and positional arguments. That's the hard way of doing it. Just do it. It's Python. It's meant to be explicit. You're not meant to get creative. So just define them all as keyword arguments, and you're good to go. So here's the plot. Now I'm not sure how to get the plot to show. They must have done an extra command here to get it to show. I have used these sorts of tools before. Let me do a help on SNS. So maybe there's some kind of thing like show or something like that. Let's do a help on so we did a help on SNS. Let's do a help on SNS.lmplot. All right, so there we go. So I don't see anything when it comes to show. So how do I show the graph? Let's ask that to ChatGPT. And another thing I can do is a help on so I can save the output here. Say my graph equals this, and now I can do a help on my graph. If we look at the data type of my graph, it's this facet grid. So let's see what we can do with this facet grid. So we can map, we can refline, we can set labels, but can we look at the grid? Can we show the grids in some way? So here's the S's. So plt dot show is the way to do it. So let's try that. So plt is not defined. That's what I thought. Let's do mygraph.show. And a facet grid has no attribute show. So I'm not sure. Oh, you know what? We have to import another module. Let's do that. There we go. And now plt.show. Oh, and nothing pops up, so not sure what's going on there. Maybe I need to do this again now that I've imported it, because it didn't register in the import. Okay. Well, something's going wrong. Anyway, not that big of a deal. I mean, it's compelling. It's like really cool to like see the graph. So it would be nice to get this to work because it's so compelling to like see the graph. So didn't work. Didn't show anything. Okay, so let's try this. Let's try MATLAB lib inline magic command. So MATPLOTLIB dot inline. And MATPLOTLIB not found. So I'm not sure what's going on with that. Now we did use PL show and it did work, but it didn't actually show anything. Yeah, so it looks like there's a lot of steps here. And it looks like this is for the Jupyter notebook, which I don't have the Jupyter notebook working. I probably need to get that working. All right, I'm just gonna move on. I got it to work to get that object, so I can concern myself with that later. I think the issue is I'm not using a Jupyter notebook, so I'm missing an entire step where you can actually see this. The place where you can see this, I don't have set up. All right, so moving on to descriptive statistics. Next, some descriptive statistics can be generated. So df.describe, we can probably do that. df.describe. There we go. So we've got the count, so the number of rows there. We've got the average, so the average height is about 68 inches. The average weight is about 127 pounds. Oh, you know, if it's a sample of okay, you know, that seems fine. And then the ST, standard deviation. This is one of those mathematical concepts as well. Is like how much, you know, who is dramatically different than the average person. Like how much does that deviate? Like who like in this data set, do we have a lot of people that are all different heights, or are most people this generally about the same height? So you can get that with the standard deviation. It looks like for the height, the standard deviation is a lot lower than the pounds. So there are a lot of people of a lot of different weights, but there aren't as many people of different heights. So now the next one is the min. So this is the shortest and the person who weighs the least. So the shortest person is about 60 inches tall, which let's convert that to feet. So there's 12 feet, and there's 12 inches in a foot. So 60 divided by 12. So 5 foot something. It's gonna be, and then there's so there's 12 in a foot there. So this is like 0.128. So if we do 12 times dot or 278, now we got, so they're about 5'3", maybe. Yeah, 5'3" is about their height, a bit taller than that. And this is the shortest person is 5'3". And then their weight is 78 pounds. Let's take a look at their BMI, just because I do like, a lot of people are say like BMI is not a good metric, but I find it to be very insightful. So let's see this person's BMI. So they are 78 pounds. Okay, so this person is extremely underweight. I don't know if I'm doing the calculations correct, but in fact, this person is so underweight. I wonder if these are accurate numbers, because that's not a weight that is practical. And that's what's great about BMI, is like it can tell you like, oh, this person's BMI is 2,000. Like, no, something's wrong with your data. So I feel like something like that is happening here. And then the other thing, this is interesting. Huh. So this is the min. So the shortest person likely has the smallest weight. If there were anyone taller than this, the BMI would be even lower. So there must be something kind of odd about this, because somebody with a BMI of 13.8 would be on the brink of maybe it's a real number, but yeah. So let's no in control. So BMI 14 BMI. Maybe I'll search for that. I'm just kind of curious to see what I mean, if it's a child, I guess that might be fine. Yeah, let's use a child BMI calculator, because maybe it's different. Okay, so we're gonna say, I mean, for a child, I don't know what the difference would be there, and then I don't know what their age is. So their weight, I know that it is 78. Good job. And then their height, I know that it's about 5'3". So fraction, so 5'3", and then the fraction of an inch. They were like, so yeah, about a fourth, I think. All right, and then I don't have this other data, so hopefully I can continue without it. It looks like it is mandatory. So 5'3", that would be an older kid, right? I guess I'm gonna put like maybe 13 or 14. Let's go with 14. And then let's say it's a girl, I guess. I don't know. Yeah, so they're still underweight, even if it's a kid. They're in the lowest percentile of underweight. It's just not. It's something with the data is either going wrong, or this person has some sort of health condition. But even if they have a health condition, I think it's still a bit low. I'm not sure. But okay, so going on. So we've got df.describe. I did that. Now the next ones, and this is all at the top of my head. I could probably do to brush up on this. It's like, of the standard deviations, which people are in the 25% of anomalous results, which are within the 50% of anomalous results, and which are in the 75. So the picture that comes to mind is, you've got a bell curve of all the results, and then you've got your standard deviations here. So there'll be people that fall into this part of the bell curve. There'll be people that fall into this part of the bell curve, and then people on this side, the heaviest people, and then likewise on the other side, you've got people on this part, and then everyone over here. So it's like how wide are each of these bars? Is this really narrow where there's really not that many people that are right in the average, and most of the people are on the extremes? Is this wide? So this would be the, I believe that would be the, yeah. So the max is up here. The min would be, well, it's not parabolic data. This is the data. So the max would be up here, the min would be down here, and it's not a parabolic data. But that's my understanding of it. I probably could use some brushing up. All right, so moving on to the next part, kernel density distribution. A distribution for the density plot shows how the two variables relate to each other. So I think I can do this command. Let's try it. SNS dot joint plot height, and this would be a lot more compelling. And we're gonna do x. Yeah, using a combination of positional arguments like that is just not something I want to do. So y. And this is the kind of graph, I guess. All right, so we've got a joint grid that was successful. We can't see the joint grid, unfortunately, because I don't have the Jupyter running, but we can see what this would look like if I could print it out. It would look like this: the weight on the y-axis, the height on the x-axis, and this is the density of the data. So most people are about 68 inches and about 130 pounds. So let's take a look at the BMI of the average person. So most of them are about 130 pounds, and then they're 68 inches. So I'm not gonna trust my. So convert 68 inches to feet. Wait, is that how many inches they are? I think I did my conversion wrong, because it's in, you can just multiply it. You can just divide it by 12. Yeah, so 5.6. I mean, that's about what I got. Should be 5.6. Yeah. So let's go with 5.7 because it's closer to that. So 5.7 and then 130. Okay, so that seems like a pretty valid result. Most people in this data set are of a normal weight. They're of the lower end of that normal weight, which is kind of unusual for a data set, I would say, from the United States. I'm kind of not sure. I kind of want to learn more about where this data set came from, because that's kind of an unusual result. It's a surprising result for me. If it was from the United States, I would think more people would be on the overweight, at least, or at the very least it would be kind of on the higher range of normal. All right, so next part is modeling. I'm going to move my bookmark. I might have to end the video. Let's see here. Yeah, we got a lot to go through, so I might have to end the video. Let's see what, kind of at a neat and clean place to end it. So I'm almost at the hour mark too, 8:30. So that's it for this video. Stay tuned for the next one.